Thank you for joining everyone. We will be starting in few minutes. In the meantime, I've shared some links in the chat box that is to our LinkedIn, our YouTube, and today's feedback form. The goal of this webinar is to give you a practical overview of how the software simplifies connection design and helps teams save valuable engineering time. With that, let's begin the session. So before we move ahead, let me quickly walk you through today's agenda. We'll begin with a brief introduction of IDEA StatiCa and why it has become an essential tool for modern steel connection design. Uh, then we'll highlight some of its key capabilities and standard support within the software. Following that, we will move on to a short software showcase done by our presenter here. And we'll show you how IDEA StatiCa handles real connection design scenarios. We will also touch upon the BIM integration and how the software connects with other structures tools to streamline your workflow. Towards the end, we'll briefly cover licensing support options and finally open the floor for all the questions from you all. So by the end of the session, you'll walk away with a clear understanding of how IDEA StatiCa can be applied directly in your project workflows and in your companies. You will get a practical overview of the platform's capabilities for efficient steel connection design and analysis. You'll also touch upon some of the best practices that help engineers confidently implement IDEA StatiCa in real projects. And of course, after the session, we will share some resources such as documents, videos, and participation certificate to help you continue exploring the software. Before we begin, I'd like to introduce you to today's presenter, Mr. Kirti Chandra Joshi. He is a structural engineer at Acero. Kirti holds an MTech in structures from Delhi Technological University. He has hands-on experience in IDEA StatiCa, RISA, ADAPT, Bluebeam, RFEM, and many other softwares. He'll be taking you through the detailed technical walkthrough in just a bit. And before that, let me give you a quick introduction to what Acero Consulting Engineers are. So, Acero Consulting Engineers is focused on delivering advanced AEC tools, software solutions like IDEA StatiCa and RISA and many others to help engineering teams improve their productivity and streamline their work. Our team is driven by structural engineering expertise, allowing us to not just provide the software, but also practical guidelines on how these tools can be used in real projects. Today, we support over 300 clients across 20 plus locations and have a portfolio of more than 30 products in our engineering solution software solutions. Along with training, we also provide webinars, technical supports to our AC community. Here's what we offer. So what are the softwares that we deal in? Obviously, IDEA StatiCa that we'll be focusing on today. Other than that, we have Autodesk. You all might be familiar with that. Karamba 3D, Shuriken, Adobe again, very common software, and Aries Trinity, which is a alternative to Autodesk products. Other than these products, we also deal in primary Nimishek portfolio, which offers Bluebeam and RISA. So RISA is for integrated modeling, connection, and design. So RISA 3D floor and connection comes in that platform. We also have Adapt Builder and Adapt PTRC, which is for reinforced concrete and post-tension concrete design. Allplan, which is a BIM-based design platform for architects and engineers. Finally, we have Bluebeam. It's a very well-known software. I think you might be familiar with that, but it's a smart PDF collaboration tool for AEC professional like yourself. With that overview, let's dive into IDEA StatiCa itself. I'll now hand over to Kirti, who will take you through the software support feature. Once again, thank you all for joining in, and yeah, Kirti, over to you.
Yeah, thank you, Ashwin, and I hope I'm audible, right?
Yes, you're audible.
Yeah, hi, good afternoon, everyone. And my name is Kirti Chandra Joshi, and from here, I will take you into the IDEA StatiCa. So we'll understand the software capabilities for designing the steel connection. IDEA StatiCa is an industry-leading, steel connection design software for beam to beam or beam to column or the column base plate, and it can perform the code check of your joint based on the CBFM analysis. So basically, it is used for both the steel and the concrete design, where you can do the connection design and also the member design in the steel structure, and whereas you can do the wall design or the cross section design and the concrete details and see the concrete workflows in the concrete structure. So it is a huge database of the pre-designed 2D and the 3D connections, footings of the CSS or the SSS connections, all and also the steel to timber connections, which will definitely saves the connection design time. So as you can see on the screen, we can see that the breakdown of a cost for a typical multi-story building is around like 60 to 80% of the total cost of an end product that goes for the raw materials and fabrications. So, as a designer, so it is our responsibility to avoid, over designing of this like the steel connections, and to provide the accurate and the practical steel connection data. Basically, this not only improves the, the steel project efficiency, but it also helps to reduce the excess steel uses and the carbon consumptions during the fabrication. So ultimately, basically, the optimized connection design definitely allows us to deliver the safer and the economical solutions. So it is a user-friendly interface where you can create any typology by just the 3 clicks. And to modify your design, you will get all the real-life manufacturing operations as seen in the slide. So basically, the manufacturing operations here means all the components that are used in the steel connections, that may be the end plates or the stiffness or the splice, the welds, or the gusset plates. So, for example, in the industrial buildings or the truss structure, so different members may meet at the one node that makes the connection behavior complex. So in such the case, the stress are not distributed evenly, and as per our traditional hand calculations, this often simplify like the effect. So basically, the software helps to model this connection in the 3D, and also allows us to see how the forces flow through the plates, the bolts, and the welds. So basically, what problems are we solving with IDEA StatiCa is it ensures our connection is safe, and it also helps in the optimization of the connections and also solves the complex analysis. Other are the it is the code compliance, and you will get all the reportings and the project documentation and many more that we'll discuss as we move forward. So why IDEA StatiCa? So basically, majority of the structure fails, also fails, due to the bad design of the particular connections of the joint, which obviously affect the cost of the project and time. There is a question. So why is there is a need of the software? So if I talk in simple term, the answer is like the software is created for the efficient design of the steel structure connections that allows the engineers like us to sleep peacefully. So start with IDEA StatiCa makes the connection design much faster and efficient. Like it can help the steel connections using the inbuilt templates and the connection libraries. So instead of checking each component manually, you can model the connection and can instantly see the results. So definitely this speeds up the design process, and also the software use the CBFM, which is the component-based finite element method, which basically provides the stress following the um, stress result accurately, more realistic, and it follows all the Indian as well as the international design code, including the AISC and the Eurocode and the more. So as you can see, the software also integrates with the analysis and the CAD tools. So forces from a structure analysis model can be, imported directly into the connection design model. So here you can see that how connection design that are carried out in IDEA Statica has advantage over the manual connection design. So basically, manual design of the steel connection is obviously the time consuming that involves the multiple hand calculations and the iterations. For example, if I talk in traditional workflows, like if we want to design a moment connections or a base plate, we usually start with the manual calculations, the spreadsheet, or the design guides, and then we can check each component separately. So this process becomes the time consuming when specifically, when a project contains hundreds of the similar joints. So to this, like the IDEA Statica automates the entire design process that helps in delivering your quick and the realistic result. Like manual method may depends on the simplified assumptions, or whereas the IDEA Statica provides the high precision, maybe using the FEM-based analysis and built-in code check. So again, the visualization is the another advantage. Like instead of your 2D sketch, it offers your full 3D views of force, the stress, and the deformation. So in the example, shown in the right side, like a manually designed, SSS column splice, like typically weighs more than the same connection that is designed using the IDEA Statica, that saves the total cost for connections. So you can save both your tonnage and the cost lot more on the number of connections, like, and you can get a strong return on investment with more connections that may lead directly to the more profit. So basically, in short, like it enables the accurate and the optimized steel connections that can save both the time and the material cost. So here are some of the key features I've highlighted for the IDEA Statica that can be used for the steel connection design. So the first is, as I mentioned, it uses the CBFM analysis, which definitely allows the evaluation of the stress and deformation in the connection component. So at the same time, the software also performs the design checks, as I mentioned, like as per the IS code or to the other international standards like the AISC, Eurocode, Australian code, and many more. So basically, in CBFM, basically what it is it is the the synergy of the component method and the finite element analysis that allows to model the connection components, like whether it may be bolt, weld, or the plates, or it may be the stiffness or other components. And it basically provides the clear information about all the behavior of each of the joint or the members used in the connection design. So another important feature is the connection library, as you can see, which provides the ready-to-use templates for many of your connections type. So this definitely can save a significant amount of your modeling time. And in addition, like it generates the detailed report as per the code provisions. Like the results can be useful for the documentation, the design review, and whether you want to communicate with the client or the approval authorities. So we'll see this in our demonstration part, like how you can generate the report as we move forward in this webinar. So I want to talk about the connection library. So it is the the biggest database for the steel connections. So it is a cloud-based solution that provides the 1 lakh plus ready-made steel connections from real-life project all around the world. And basically, it's free for everyone. And connection library can be fully integrated with the viewer mode, and it suggests what it does. It suggests the design alternative based on your model geometry, the arrangement, and the cross sections, and that can definitely allows you to export the design for further adjustment. Like you can find and download and apply the perfect solutions using the connection library. Like like you need not to start the connection from the scratch. Like let's see how how this connection library works in the next slide. So here, what you can do is you can define your geometry in the first step. Like you just need to input the members and their cross-section type, as you can see on the screen. And then you can find the similar connections with the geometry directly. You can select the cross-section side so that I have selected the rectangular hollow sections. And so there are three members, and you can just give the rotations of this member, and you can just find the similar connections based on the geometry. Then after, you can just click on the source options, and you can just browse the database. So as you can see, you can just browse the search result, and you can just refine them using the filters options available at the left-hand side, like the connectors and the features to match your model arrangement, including the member count, geometry, and the cross sections. Like you can include whether the in-plate can be used or whether the splice. So you can just filter out. And then after, you can just click on sign in. Like you can, if you have already an account, you can just sign in with your IDEA StatiCa login details. And otherwise, you can just create a free account to access the connection design. Also, you can just open the model in the viewer for 3D, or can definitely download the model to your desktop for further use. So here you can see that the IDEA StatiCa can design the connections that can vary from the simple beam to column joint in 2Ds, frame to the complex 3D node, like the gusset plate connection, the bracing, and the heavy column encoding system. Like these are few of the examples from others which you can definitely create within this software. Like you can take any of the template and keep editing it to any of the typology and loading. So basically, in a real project, like we often see the multiple members meet at the different angles, like making the manual design difficult. Like so, IDEA StatiCa definitely allows us to model this real geometry directly and visualize the stress flow in your plates, bolt, or the weld, and can perform your code check in just one platform. So you can also carry out various types of the connection, whether it can be a moment connection. So I have some kinds of the moment connections here. You can also carry it out like the shear connection, brace, splice, base plate, and more. Like you can design connections of any geometry, any loading from scratch, or import it from your analysis software. Then you can visualize the connection behavior and generate the connection sketch and the bill of material as well in the reporting part. So as you can see here, like the IDEA StatiCa is used in the wide range of the real projects. Such it may be the stadium roofs, the warehouse, the industrial halls, the bridge, platforms, or the power plant or the airport structure. So basically what it shows is this project involves, the complex joint where multiple members connect in different directions. So it allows to, model all this real condition accurately, and also verify them according to the design code. So yeah, this helps to deliver the shape and even the optimized and the fabrication ready connection design, even for the the highly complex structure. Here, the software can performs the the connection check according to the international code such as the Eurocode, AISC, Canadian, or it may be the Australian and the other global standard. So importantly for the Indian project, it also supports the IS 800 for the steel design, where bolts, welds, and the steel component are checked, it's for the Indian provision. And it also includes the IS 456, which is used for the concrete compression and the encoding check. So, like there might be the question like how to verify the steel joints for the IS 800 if you are working on the Indian project. So basically, like in the steel project, for example, like the PEV, the industrial, and the oil and the gas project, like where your joints are often involves the heavy shear or requires the large moment and basically the thick plates, and even it may require the multi-row bolt arrangement. So if you are comparing or if you're analyzing by just the traditional hand method, you may need to struggle to capture the effect like the local yielding or the prying action or the plate buckling. So with the IDEA StatiCa, with the CBFM analysis, like you can easily evaluate the plate deformation, the joint stiffness, or it may be the weld stress that may be distributed within a single IS 800 workflow. Like it also helps to validate, whether the connections behave as the pinned or the semi-rigid or the rigid. And then it can provide the verification for all of your members and all your components. Yeah. So moving forward, so IDEA StatiCa will analyze a model, but also do the code check as well, like I mentioned. So you can carry it out different types of the analysis, like the stress strain, it may be the stiffness analysis, the capacity design, the buckling, and more, just to evaluate the real behavior of the steel connections. So basically, its main focus is on, the connection designers get the maximum design confidence and the peace of mind. That's basically the IDEA StatiCa for steel. So now, like using the CBFM, like I mentioned, so it performs the stress strain analysis by default. As you can carry out the different types of the analysis, but stress strain analysis is carried out by default. What it does is to see it calculate the resistance of each component, where the strain check of the plate together with the code check of the component are performed. And the next is the buckling analysis, like is used to verify the plates or the parts of the joints are too slender, or it also calculates the buckling factor and the corresponding buckling, like the limiting buckling factor are set according to the design code. And stiffness analysis is used to determine the connection behavior as the pinned or the semi-rigid or the rigid. And definitely the software also allows to carry out the capacity design check. Basically, they are important for the seismic structure, just to ensure that the plastic hinges are formed in the intended location. And you can also carry out the joint design resistance, and we'll see the certain types of the analysis in today's webinar, and we'll cover other in our upcoming webinars. So moving forward, like in IDEA StatiCa, so basically the plates are modeled using the shell elements, and it allows the simulations it allows the accurate simulations of a flange or the waves and the connecting plate. And each of the plate is, independently meshed to the equivalent to evaluate your equivalent stress or the strains and the overall utilization. That definitely helps to identify the stress concentration and verify the plate performance in connections, whether it may be the in plate, gusset, or the base plate. So component welds are modeled as the solid elements, like which are connected to the plates. So the stress in the welds are distributed using the plastic analysis. So as shown in the slide, you can visualize the 3D distribution in the weld and the equivalent stress values and the detailed result tables as well. So I mean the force in the each of the weld element are evaluated, and the stress in weld is calculated according to the available codes. So whether it may be the AISC, Euro code, or the Indian code in many other codes. So this is regarding your like how you can import a connections from any of your finite element analysis software to the IDEA Statica. Like if you want to import your connections from ETAPS or STAD to the IDEA Statica, then you can use this feature. So basically, IDEA Statica have a feature called checkboard, like which will automatically generate the internal force for your joint from the applied force in your global analysis software. So now for importing the joint, as you can see left-hand side, we just have to select the required joint and the members, and you can just export the connection into the IDEA Statica using the checkboard. And then once you have used the checkboard, then you can just adjust the load, or if you and you can just start designing, and the output will give you the overall code for like the code check. IDEA Statica automatically links with your, software to let you export and synchronize your data. Uh, like um, Whether it may be your ETAFs like the SAP 2000 StatPro or the Timble Tekla structural designers, and whether you are referring to the CAD programs, then you can export from the Tekla structure or the Autodesk Revit and the advanced steel. So the geometry, even the profile and the plates, bolts, and the welds are, automatically exported into the IDEA Statica using this feature. So I have created a short video on how to analyze regarding the IDEA Statica interface, and we'll also carried out how to perform the typical moment connection in IDEA Statica, and we'll observe the results. So let's have a look. So this is the interface of an IDEA Statica, where in the left top side, you can see the connections members. So it can be used for the member design as well as the connection design. And it do have the connection library, and it's also used for the concrete structure. So today we'll focus on the connection design. So we'll click on the connection design, and the new interface will open, and which allows you to define your the geometry and select the design. Basically, this is the templates that are available in the IDEA Statica. So you can select any of the templates, and so for the base plate, there are lots of the templates available. So the column may be the I sections or the square sections. So you can select as per your requirement, and it has the templates available, and you can just select, and you can just click on create selected design at the bottom right, whether it has the connections templates for your bracing, also for the splice. So different types of the templates you can easily get. So this is for the splice. So we'll take one template for the beam to column moment connections. You can start from scratch also. We'll also show how to start from scratch. Then we'll also show how you can generate using the template also. And in the material part, like in the below, you can just select the design code. The code you must select while you select the template. Later, you cannot change the code. Like if you select the Euro code now, then you cannot change the code at a later part of your connection design. So once you click on generate, the connections model is been created here. Then you can just edit your operations, the manufacturing operations. So there is the in plates available here. So as you can see, the in plate, you are not able to edit the in plate, but once you click on the right click and explore all the templates, then you will be able to fill the required data and edit all the parameters. So this is like how you can use any of the templates and performs the connection design. But today, our main focus is on how you can perform the connections from scratch. We'll add members, and we'll add the in plates, and we'll change the arrangement for the bolts that we are going to see now. So I will just close this one, and I will just click on the connections options. As you can see, again, the same window opens, and in the left and in the below left side, you can see the create blank model. You can just click on that. So before clicking that, you can see on the left-hand side, once you click on the different options that are available about and the preference, you can see the versions of your IDEA StatiCa, and you can definitely change your settings. You can change the logo, and you can see the license information once you click on the license options. And you can also click on using the blank model. So I'm just giving the connection name as moment connections, as you can see. So I've selected the code as it is, and the new window opens. Here, the connections interface is blank, as you can see. Earlier, we have generated the connections using the template, but we are going to create the connections from scratch here. So once you click on the project options, then you will get the window where you can fill your informations, the name that I have filled my names, and you can fill your description. You can see the dates of where you have when you have created your connections. So I've just given the connections name, moment connections, and the author name, and you can just fill out the description. Once you fill this data, you can just save it in any of your folder location. So I will go again back to my screen. Now you can see I have given the connections name as moment connection that is displayed in the top sections. Now we will add the members that is available in the design tab. In the right hand side, you can see the member load and the operation option. So we are going to add the members. So there are lots of different sections available for the hot roll, the cold form, the build-up section. So we are going to use the I sections, hot roll steel sections for our columns and the beams. So you can select all the sections from the available list. It do includes the IS 808 sections as well. You can see the SP, MB, or the JB sections. So, but now we are going to create with the UC column. I will select any of the sections just for the demonstration purpose. And you can just click on OK. Right now you can see I have, add one of my members, but as you can see, it is not the continuous member. So we can just change the setting from the right-hand side. You can see the properties of the M1 member. M1 is my this members. So you can just change the setting, and you can just give the orientations also, it is if we want to make our columns, we can just give our directions by 90 degree. So I'm just first making it as continuous members and just using the pitch as 90 degrees. So it has, so I have created my columns. Then again, we'll add another member that will be my beam members, as you can see, but we don't want the rotation of 90 degree here. We want to keep it as a horizontal. So we are giving a piece of 0, but we want to use it as an end member so that it connects, the end of the beam connects to the flange of the column. Again, we are going to add a member M3 in the other directions. So, but we can also give the sections to our beam. We can give, I will use the UV sections. You can see all the sections that are available within the IDEA StatiCa for the hot roll sections are available. So you can select any of the sections. So I will use UV sections for my beam, and for my other beams, I will just add other beams and use the same property by using the copy feature. I will just use the copy, and for right now, I will just give a direction of 180 degree so that I will create the beam on my other end. Right now, you can see we have added a beam and the column. The next is we're going to add our operations, that is the in plate. Next to the member, you see the operations or you see the operation option. So once you click on any of the operations, you will get all the manufacturing operations that are available in the IDEA StatiCa. So there is the stiffness, there is the widener, there is the splice, there is the weld. Lots are available, but we are going to use the end plate. So once you click on any of the operation, it will display which operation is it. Like once you click on gusset, it will display gusset. So for now, we are going to use the in plate. Right now, you can see in plate has been created, but meanwhile, in the left hand side, you will see once you click on any of the operation, its property is displayed in the right hand side. EP in plate is displayed as the EP1, and we are going to define the parameters. So right now we have created the in plate on member M1 and member M2, which is connected on M1. But we can see in the member M3 there has not been in plate. We are going to define this on member M3 also, and going to connect it to the M1. So yes, you can see on the property options. So you can display all the member information and the plate information through the member and the plate options available under the design tab at the top. You can also generate the coordinate system as well. So we are going to create on the member 2 also as M3, and where we are going to define our in plate. So in the member M2 and M3, we have defined the in plate, and that is connected to the member M1, as you can see on the property tab. So you can definitely change the steel grade as well, and you can define its thickness. And below, you can see the connection type is bolted. And right now you can just see the top, left, bottom, and the right options where we are going to give the dimension for our end plate. So I have extend it at the upper part. So we can use you can use it you can just edit your plate just by giving the dimension. And once you do this, then you can just change the bolt configurations, and you can also define the bolt type. M24 8.8 I have used right now, and you can see the top layer, left, bottom, and the right layer as well. You can see right now the bolt. I will change this bolt configurations. I will just make the 8 bolt in like that. I will 8 bolt in one column, one beam. Right layer, I will just use the one layer. So once you provide the gap, it will display it in your 3D model as well, like whatever the spacing and whatever the distance you have provided. I will create the 3 bolt arrangement at the top layer. So I have make a bolt arrangement of 8 bolt in each beam. And you can definitely change the weld property. So I've used the fillet weld, double-sided fillet weld, and you can change the fillet thickness for the flange and the web. For this, I am using the 8 mm fillet just for the demonstration purpose, and I'm just giving a lower on the web side. The weld is denoted by the yellow in the model. You can just rotate it, and you can just visualize your 3D model as well. Right now, you can see I will just change the bit of configurations to my plate. Now I think this looks okay to me. Right now, the weld is properly connected. from the beam flange and web. Also, you can set the material to a weld as well. So we have carried out the connection, like we have added the members, we have added the bolt operations in the plate operations and have assigned the bolt configurations. Then after we will add the loading and we'll just run the analysis. You can just measure out the dimensions by using the measurement tool. So next is we are going to add the load. So we are going to apply the shear and the moment. So you can just open your local coordinate system as shown on the design options. So I am using on both ends of the both ends of the beam, shear load and the moment. Here we will just we are using the shear and the moment. And we'll carry out the stress strain analysis. And in the later stage, we'll check out the design joint resistant and we'll check what will be the additional or the surface moment capacity that my model will carry out, and we'll just evaluate it. As you can see, I have applied the moment and I have increased the shear load. As you can see in this end, it is a clockwise moment, and in the other end, it is the anti-clockwise moment. You can just rotate a model. So we have applied the load, and in the project setting, again under design tab, you will see the material grade, whatever the material or the bolt grade you have used, and you can also change out analysis setting, and you can set out your cost setting also. So in the analysis setting, you can just check the partial safety factor that are used for your codes, and as well you can see the also for the check, like the plastic strain limit that we are considering it as the 5%. You can just set all of the setting in your project setting options, and add the user preference options that is available under the cost. You can set out the symbols. You can just set out your rupee symbol if you are evaluating it for the Indian project, and you can set out the cost for the steel, the cost for the weld and the bolts, and it will IDEA StatiCa will calculate the cost estimations in your report as well once the analysis is complete. So you can set out the cost for all of the steel parts. Right now in the screen also, you can see the production cost has been calculated based on the values you have entered here. So I'm just giving it as a by default, but you can definitely change this value. So we have already created the beam column in plate moment connection, and it applied the load. And now we are going to calculate the model. It will take some time just to run the analysis. And once you run the analysis, then in the left-hand side at the top, you will see the summary result. The analysis 100% loading has been applied. And for the plate, it considered the 5% of the strain limit. And for the bolts and the weld, the utilization ratio has been displayed accordingly. Right now, all of my model is passed, but we have not calculated the buckling. You can also calculate for the buckling as well, buckling check, and it will calculate, it will give you the critical buckling factors, load factors for the buckling. And once you go on the check options, you can just check out your stress and the strain within your model. So I will just click on the plastic strain and use the mesh shape. As you can see, the significant strain has been developed locally on my junction at the flange junction. So also for the stress, it has method of the stress has been developed in my web. You can just evaluate all of this check. Once you click on the diagram, you can also zoom in as well. As you can see on the left hand side, once you're on the analysis, and you can see on the check options, you will see all the analysis for the plates, welds, and the bolt components. And you can evaluate your stress as well. Similarly for the bolt also, once you click on these plus icons for each of the bolt, it will give you the calculation steps that has been performed, and you will see the utilization ratio, bolt utilization ratio as well. You will see all the tensions, bolt taking the tension force that has been calculated. You will get all the checks. So basically my top flange, so basically my bolt force at the top are taking off the tension forces because we have applied the gravity load. So the top flange, so the top flange carries the tension, and the bolts at the top force are mostly the tension. And while we design at the manual also, we at the lower flange we design it for the shear. And we will also, so as you can see, the bolts at my lower at number B7 and the like the B7 and the B8, we are getting the bolt force of 1.7, which is basically very less bolt utilization. So you can just evaluate and cross check this as well. So once you click on any of these options, you will see the bolt force. You can just generate your bolt force. You will see the options of generating the bolt force at the top. My point is, you can just using this stress strain analysis, you can check out all of your components like the plate, welds, and bolt, and it will give you all the calculation steps as well. So for this loading, we see that our model is performed well, but we are going to see like we'll also going to carry out the joint design resistance. Basically, it helps to estimate, the reserve in the connection resistance. Like means you can get the design capacity of your connections as a percentage of your applied load. Like basically, the designer, usually solves the tasks of designing the connections to transfer the design load, but it is also useful to know like how far the design from the limit state is, that is how big the reserve in the design is and how safe it is. So we are going to check this. For that, we are going to create another model, copy of this model, and we'll perform the different analysis. So as you can see on the left hand side, the analysis type right now is the stress strain. Once you click on the drop down, you will see the different types of analysis that can be carried out in IDEA StatiCa, the stiffness analysis, the capacity design, the joint design resistance. Today we'll cover the stiffness a bit and the joint design resistance. And in the later part, we'll describe more of the other webinars in detail. So we are going to create a copy of these connections, and once you click on the drop down, you can see the connection has been named as 1. And you can just click on design joint resistance, and you can just click on calculate. So now you can see the analysis has been calculated for my design joint resistance. And in the check options, you can see right now the joint design resistance, a factor of 172.4, means you can get a sort of you can you can just increase your load like the moment by 72.4%. So it is the additional capacity that has calculated for me. So what we are going to see is we'll go back in our same model, and we'll just increase our load by a factor of 1.72, and we'll check how this model behaves. So 322 into 1.75 is normally 550 around, but we are going to take load of 535, moment of 535, and we'll just run this analysis. Right now, you can see the bolts and the weld utilization has been increased, and it is in a critical state because it has calculated me like how much of the additional moment it can take, like how the connection can take how much of the additional moment. So this is the way you can verify your additional capacity for your connections. You can also see the plastic strength has been developed in the below portion as well. In the you can also generate out the stress. Right now, all my waves are stress in the wave region as well. In the um, beams are also increased. So right now we'll also increase to more than 1.75. So we are going to increase by 550, and we'll see if this can take our moment or not, if this connection can take our moment or not. So right now you can see the bolts and the welds have been failed. So by joint design resistance is used, basically to calculate how much your reserve is for like how much of the additional moment your connection can take. So you can just use this analysis. So stiffness analysis, we are going to evaluate like basically it is used to determine whether the joints are the pinned, the semi-rigid, or the rigid. Basically, you will get the classification of the connections based on the different standard. Like basically, so we will see, we'll just keep the same load of 320 kilonewton moment, and we'll just run the analysis. But this time we are again going to create a copy and just run the stiffness analysis. So you can just go on the check option at the top and the rotational stiffness. So basically it will calculate you the second stiffness and the rotational stiffness for the joint. And as a result of the stiffness analysis also, you will get the moment rotation diagram and the table with the several values based on the curve and the selected standard. The joint is classified as different, like the pinned, semi-rigid or rigid, but now in our case it's the partial strand. So you can also run the buckling analysis also, but now once you've carried out all of your analysis and the connection design looks fine, then you can generate the reporting part. So for that, we are going to see how you can generate the report. As you can see, you can see the color-wise options, basically the green and the gray and the orange color defines the check level, like the optimal check level for your green and the warning check level for your orange color. You can also define the loads. We can just define the loads as a percentage fact form as well. We're going to cover all of this in our upcoming webinars in detail. So you can also import and export your load. So in the check options, in the report options at the last, we are going to generate the report. So once you click on generate, you will generate a report. You can see the options of save. You can also save as, you can also export it to IFC as well. Yeah, once you click on the report, so the report has been generated and you will give the options of printing the report in the DXF, or you can get the options of one-page report, the detailed report, or you can also export like the report type as the BOM, bill of material only. So you will get all the information on your result, the project name and the information that we have filled, and the image for your 3D model of your connection types and the check summary, and all the stress strain check for your model, and for all the components, weld, bolts, and all the code setting that has been applied. So moreover, in the right hand side, you will see the options of various settings that can be applied. For example, if you want to include the formula or the explanation of the cost estimation in the bill of materials in your report, you can just click on these options. So right now I'm clicking on generating the formula and explanation and bill of material, all of these options. So you can just click on generate and it will gives you the detailed report with the explanation and the formula. So it is up to you, like how you want to modify a report. So you can see all the code check and the steps for your welds, bolts, and the plates components. Because we have generated the detailed report. Also, we have calculated the cost estimation as well as the bill of the material. So it is also included in the report with all the drawings. You can see. And again, in the left-hand side, if you want to include the IDEA StatiCa information within your report and the theoretical background, you can just click on these options as well, and you can just generate the report accordingly. So it is the same report with the additional software information, like which version of the software you are using, and and again, there are some theoretical informations regarding the software, like the CBFM analysis and the loads and the plate and the weld check verifications, that you can include it in a report and share it with the clients or the authority approvals. So we have created, we have seen like how you can start a connection from scratch, and how you can analyze, and how you can generate the report. So it also supports the integration with measure analysis and the BIM software, such as the ETABS, STAD, or the TechLight structure, and the Revit. And using checkboard, like models and loads can be imported from like they imported directly, which helps in reducing the manual work and enables the the connection design workflow much faster. So after doing the analysis, you can generate a detailed report, as we have already seen in our workflow part. So if you explore the case study for the IDEA StatiCa, you will see like how engineers and designers around the world use this software to solve your complex steel connections challenge, and it provides the range of the real project and the case studies available on the official website, where users can review the application in maybe the industrial structure or the bridge or the stadiums, or for example the commercial buildings, and many more. So in addition, like it also says the video success story on the YouTube, like where you can hear directly from the engineers about their experience with the IDEA StatiCa. So I have added the snaps of the IDEA StatiCa story as seen on the bottom right. So you can explore all of these case studies. So to summarize that, what we have covered an overview of the IDEA StatiCa for the steel connection design, and included its key features, analysis, capabilities, and the supported integration. So we also saw how to model and analyze the moment connections during the software showcase. And we reviewed just like how to access the case studies. And yeah, I believe that this session was helpful in giving you an introduction to the capability of the IDEA StatiCa. So in our upcoming webinars, we'll try to cover the specific topic in more detail, so that we can explore the advanced connection design concept, like step by step. So we'll display some poll questions here, and then we can take a few questions, yeah, frequently asked questions and questions from the participants.
Thanks, Dr. PT, and I'd like everyone to, I'd like to encourage everyone to please, contribute towards our goals. It helps us get a better feedback on the webinar and understand your use case scenario so that we can, cater this webinar or the upcoming webinar towards your actual usage. So yeah, please do contribute to the goals. And yeah, lot of contributions. That's always nice to see. So thanks. And yeah, thank you, Kirti, for that valuable insight into software. And to everyone, there is a Q&A session right now open to everyone. And you can find a chat box on top where you can put your questions in, and we will try to answer most of them right here and now. If not, we will revert back to you personally. So, TT Mr. Sandeep has asked that does IDEA StatiCa consider bolt eccentricity in its analysis? If so, can you show how it appears in the results using a simple extent shear plate connection between a beam and a grinder?
Yes, it considered the bolt eccentricity also in the analysis. Like if you want to use, you can also carry it out the eccentricity. You can apply the force eccentricity also. So we will basically it can be possible, but I will try to send you a recorded video on this after this webinar. But yes, this can be possible.
Sure. Or we can book a demo session. So
Yeah,
since
we can.
this is a public gathering and public webinar, we try to keep it restricted towards everyone's interest. But Mr. Sandeep, we would definitely love to have you for our personalized webinar, which is around 20 to 30 minutes. Open to all. So if you want, you can invite your team as well. Then we can cater to personal questions and show you personally how these many things can be done. Right? Any other questions? But the short answer is yes, it does calculate in its analysis. Any other questions from anyone? So there is a Q&A chat box. We would love to, have that. So Kirti, we can just go to one or two questions that we usually face with our clients, and move ahead if there are no other questions. So for one of the questions that we usually get is, does IDEA StatiCa support encourage design as per Indian standards? Also, could you please confirm if an RC check function is included and usable in the steel license?
Thank you for the question, Ashwin. So yeah, this is the frequently received question on the base plate. So yes, IDEA StatiCa license include the check for the base plate, weld, and the anchors, and the concrete block. So it also introduced the anchorage check as per the Indian standard also right now as per the IS 1946 part 2 and part 3. So, but IDEA StatiCa, steel alone does not include the reinforcement check. That can be something done in the IDEA StatiCa detail. Like basically the workflow is you can model and check the base plate in IDEA StatiCa steel, and then can export the model to the IDEA StatiCa detail to model the reinforcement. So also the IDEA StatiCa detail is, the concrete design software for all the details check. Like you can design the reinforcement in the detail, but only on the IDEA StatiCa steel, it can check for the anchors. The concrete check it can done, but it cannot design the reinforcement. I hope this helps. So maybe we can cover one complete topic on the base plate in our upcoming webinars.
Mr. Saurabh has asked another question. So while we check for insert plate attached with RCC column, does it check for breakout failure as well?
Can you repeat the questions?
While we check for insert plate attached with RCC column, does it check for breakout failure?
So for the IS code, certain checks are limited, like the concrete breakout failure is still limited as for the IS code, but for the Euro code and the American code, it does. since it performs the encourage checks for the IDEA StatiCa, as per the IS 1946, like I mentioned, the breakout failure and some other checks are still limited as per the Indian code, but definitely with the Euro code, you can carry it out.
Thanks a lot for that, PT. Another question from Mr. Shailesh is that does IDEA StatiCa cover the design aspect as per IS 800 Section 12 seismic requirement for steel connection design?
So basically, for seismic connection design, you have to calculate the load, and you have to apply. Basically, it will not automatically calculate the seismic load, but you can calculate it manually and apply, and you can perform out the capacity design. And by this way, you can carry it out. Like I have shown today is the stress strain analysis. To capture the seismic effect, you can carry it out the capacity design that we can carry it out in our upcoming webinars again. But the force, it will not calculate automatically, but we have to apply the manual load.
Another similar question is that from Mr. Gaurav is this software designing the bolted connections as per chapter 12 of IS 800?
So it is again the same question. I think it is regarding the seismic. Yeah. So like I mentioned, the force you need to calculate and you need to give out the value, but you can carry it out the capacity design analysis.
Bolted connections. So I think it's the same question, right?
Yes.
Okay. Okay. Any more questions? So there might be one more in the Q&A chat box. I'm having to switch from Q&A to regular chat. So in some cases, Miss Monica, I think, has asked, in some cases, column and beam are shows falling in IDEA StatiCa, but those members are safe in stat. Why such difference if there's she's trying to compare stat and IDEA StatiCa, and there is a difference in the results.
So yeah, maybe you are talking about the member design using the IDEA StatiCa Steel. So basically, you need to check all of your. So basically, you need to verify that whether you have exported that member from the analysis software or you have just created in the IDEA StatiCa itself. Like basically, you have exported that using the checkboard feature from the STAD. Using the beam link like the ETAPS or the STAT or another software. Basically, it depends on different analysis. Like basically, it performs the material like the GMNI analysis, materially and geometrically and materially non-linear analysis. So you can set all of this in your port setting. You need to check all the Seftofacti and all of your limiting strength values. So sometimes you need to set that in your code setting that is available in the IDEA StatiCa project setting options. So it may be because of the setting. So, but we need to check the models, like what actually the issue is due to. You can send us your models through the email and we'll check and we'll get out back to you. But most of the cases, you can just adjust the setting in your project setting.
Sure. We have some few more questions, so we'll take these last three. Mr. Kamlesh is asking that is the force and momentum can take directly from analysis model for connection design?
Yes, you can definitely. Yes, we do have a feature called checkboard in the IDEA StatiCa, which will automatically import your force analysis result from your analysis software. Like if you have carried out the global analysis in your ETAPS or the STAT, then it will export all of your internal forces from your FEA model directly to the IDEA StatiCa using the checkboard features. Yes, it is possible.
Another question from Mr. Gaurav is that do we get detailed calculation results for all type of connection design, or is it just a summary of the design?
Can you repeat?
So basically, he's asking that do we get detailed calculation results for all type of connection design designed in the software, or just the summary of the design?
No, you will get the
detailed.
You will get the
connection.
detailed report, you will get the detail, you will get all the summary, you will get both of it, and it's just up to you like how you want to display it. You have the settings to control it, but it will calculate all of your detailed result, including the limit state code check, which clause it is checking for the particular weld, particular members for shear bending torsion. So it will give you all the code check as per the clause of the code as well, and you can include and you can exclude that in the report options.
Thanks a lot for that, PT. So last two questions. Is it possible to check slip critical behavior for anchor bolts in bearing analysis anchor bolts? I'll
So for
repeat.
the
Is it possible to check slip critical behavior for anchor bolts in bearing analysis anchor bolts?
So I think regarding this, I need to check it once. But if you are comparing it for, I just wanted to know, you are referring it with the Indian code or some other code. Maybe in the Indian code it is limited, but with the EISC or the Euro code, it might be possible. But I need to check it once and will reply to you on this via the email. But you can just mention which code you are referring.
Sure. So yeah, due to like time constraint, we'll just take this one final question from Mr. Balakumar. He's
Yeah,
asking
referring
that
to the AISC code,
AIC.
I think it should be possible. So I will just check and we'll let you know over the email.
Okay. Mr. Balakumar has asked that do we get detailed calculation of the members which are in IDEA StatiCa library only, or any member we can design are
I-
from their own direct
You can,
dimension with their own design connection and asked for detailed calculation in the software. Can we do so? Basically, asking is can the detailed calculation or results be done only from the library or from his custom design connection as well?
you can, yeah, you can do for both. So basically, it has all the inbuilt libraries also. So you can definitely take out the section and you will get all the calculation details. So also you can define your custom sections as well. And yes, both is possible.
Yes. Uh, Thanks a lot, Kirti. So with that, we thank you all for a lot of questions. We really appreciate the engagement here. Moving forward, we can go ahead with the PPT. So yeah, if you would like to explore IDEA StatiCa yourself, we encourage you to try the free 14-day trial. It includes all the set of features and comes with full support. All you need to do is just write to us at solutions@acero.in. The website mentioned in the email ID mentioned in the lower left lower left bottom on the screen. Yeah, and we will help you out with the uh, trial. Right. Coming to this software support and licensing. So at Acero and IDEA StatiCa, support is a priority for us. So for customer support, you will get dedicated channels like phones, emails, and online help as well. We take pride in our response time and the quality of service. You can experience that by taking the demo and or the trial, and we'll help you understand them. Coming about the licenses for licensing for IDEA StatiCa, licensing for IDEA StatiCa is done for with a cloud-based licensing. So it will be a cloud-based license, not limited to a single machine. It will help you, switch users, and you can be flexible with the license software licensing as well. Finally, learning resources. There are a lot of learning resources available, but we understand that it might be difficult for you to, gather all the resources. We have a portfolio of all of these webinars, tutorials, and FAQs and all that. And once you are onboarded as a client, you want to go through a training period with your team, we can help you with that as well. You can also watch all the YouTube, you can also watch all our previous webinars on IDEA StatiCa through our YouTube page. That's mentioned on the screen as well. Yep, that's all. Here are the IDEA StatiCa users that are currently using the IDEA StatiCa software for right now. So as you can see, a lot of national and international companies, mostly international companies, use IDEA StatiCa, and it's a very robust software used worldwide. not only in India. Coming to the next screen. So what's next? Next, we have some upcoming webinars. Firstly, we have HUD App Builder, which is set on March 27th. It's a software for analysis and design of reinforced concrete and post-tension concrete structures. So we would love to have you all there as well. And finally, we also have IDEA 3D webinar coming up next month, which is IDEA 3D. It's an advanced software solution for 3D analysis and design of structures across structures like steel, concrete, timber, and aluminum, and more. Right. Now then, here are some of the contact details if you would like to note them down and contact us after this webinar. We would love to hear back from you, get a feedback from as well. We will also share a short feedback form with you. We have shared it in the start as well. Please do fill the feedback form. It helps us, cater these webinars more to your liking, more to how you want our next webinars to be, and it helps us understand our clientele as well, right? I've shared all these links to our website, LinkedIn page, and feedback as well, right? Please do fill the form, and please do share your ID person or the procurement person details with us. It's at the bottom of the form. It will help us, not only skip calling to you all, because we also understand that you might not be interested in the calls for probably sales and software sales related. So we understand that, but your IT team might be looking for some offers that we can definitely offer with them. So yeah, it was a great session. Thank you once again, Katie, and thank you all for joining in. Really appreciate the engagement today, and we hope to see you in the next webinar. Thank you, Katie. Thank you all.
Thank you, everyone.